leaving the farms and getting out to the Great Barrier Reef. Apparently the scientists tell us that when it goes out to the reef, it creates algal blooms, but that seems to have gone off the radar a bit lately. Now they're saying that, and I've got no evidence to refute this, by the way, I sound like a skeptic, but it triggers the crown of thorn starfish to multiply. Apparently the nitrogen in the sediment, it stimulates them, and all of a sudden you get a bloom or a heap of these crown of thorn starfish which drift down and eat the reef. You've probably all heard about that. So the challenge, I guess, is for the industry to stop the nitrogen moving off their farms. And indeed, most farmers would prefer to have the nitrogen stay on their farms. I think you'll agree with that. So the barriers that we face, so like as I said, I've been around for a long time, and historically the Great Barrier Reef Marine Park and the scientists, all you read about is cane farmers are killing the reef in the newspapers, you know, and this has happened over years and years and years. The farmers had no evidence to say they weren't, but and I think this is the barrier now is that you know, the barrier is not knowing what's actually happening on our farms. You know, we'll have to believe, until we've got evidence of our own, we'll have to believe what the scientists at the Great Barrier Reef are telling us. So I guess the solution is to find out what's actually happening on our farms, so that we can either refute what they're saying, if we're not losing the DIN, or the dissolved inorganic nitrogen, or we can do something about it. And I guess this is this brings us to this point where a lot of you may have participated in the Water Quality Pixel project. So we did a bit of a milk run. We got farmers test strips, and to try and give them an indication of what was going on their farms. It was very successful. I think we had nearly 200 farmers involved in it. So it was a real effort to get the farmers taking ownership of the issues, to find out what's actually happening on their farm. But the big problem with taking samples is you really don't know what happens in between samples. So, you know, there's a lot of guesswork. So you can't really refute the scientists that are telling us you're losing a lot of nitrogen if you take a sample 1 week and then 1 week. But it was good to get farmers on board and start thinking about these things. But just recently they've developed this technology that you can measure nitrate by UV light. And nitrate is one of the big ones. Of course, the other one is sediment, but the vertical farms tend not to lose sediment because everything's so flat. It's a little bit of a problem in the grazing land, where there's gully erosion and that sort of thing. It also measures COD, which is chemical oxygen demand. And the chemical oxygen demand is anything that will eat up or use the oxygen in the lagoons. And you know that you get fish kills in the lagoons after it rains, or if you green cane harvest, or even after harvest, your runoff runs into the creek, quite often you'll get fish kills. But it measures those 3 parameters. So I just happened to be Googling, you know, 10 years ago this instrument wasn't available, and you know, if you had to get analysis done, you had to take the bottle, and either if you had a lab somewhere handy, you'd analyse it, or you'd send it to Brisbane, which was more the case. And you wouldn't actually get your results for a month later. And the farmers really, by the time you get the results back to the farmers, they've forgotten what was going on at that time on their farm. But with this technology now, with the UV light, we can give results instantaneously. And I'll just briefly run through this this trailer, show you what the trailer, and then Tiffany will go through and she'll give you some results and where it's being used at the moment, and well, not necessarily where it's being used, but it's being used in the Burdekin in little catchments with farmers. So, yeah,
do you want to have it pumped through, Tom?
Yeah, okay, we'll start it up. We've got a couple of drums of nitrate solution here, and this is, well, I'll just explain to it. So we've got a vacuum pump, So you don't need any pump in the creek, or you can put it at the end of your drainer in your recycle pit or whatever. And the vacuum pump, when we turn it on, it'll pump up into this cylinder here, and the float valve, electronic float switch, will turn the pump off at the right time. And there's a little EC sensor in there, so it'll measure salt as well. And then at a given time, it's all programmed by this programmable logger. It does the timing of the events. So when it's full, after a minute or so, it'll open the gate valve and will run through the instrument. This is the instrument here that does all the work, all the smarts. And it's about $25,000, so probably not every cane farmer's going to go out and buy one. Is that right? And so it runs through here at a sort of set rate and runs to waste. And it's programmed to take 3 readings and then average them. And Tiffany will show you that when we do it. The trailer is also fitted with, by the way, this is the thing that goes into the drain, and we can be 20 or 30 metres away and still pump up. And we've also got a depth sensor, a pressure depth sensor, which tells us the height of the water in the drain, so we can calculate the flow. Because it's all very well knowing concentration, but if you want to know the amount you're losing, the flux, then you've got to get the volume as well. So the magic formula, Jason will tell you, concentration equals?
Flux equals volume by concentration.
Yeah, sorry, tried to throw you there. Flux equals concentration by volume. So this will give us the concentration, and the depth sensor will tell us how much water is flowing past with a few calculations. So we can tell how many kilograms of nitrogen leaves your paddock, virtually. And eventually, well, if it goes into the Barata Creek or river, it'll end up out in the marine environment. So we'll just do a dummy run, Tiffany, yeah. And then I'll let Tiffany take over. So there's a second pause. So the good thing about vacuum is you haven't got a pump in the creek and impeller to get clogged up with weeds, and it's pretty effective in pulling from a fair height. So you'll notice that cylinder is starting to fill up with water now. And when it gets to the top, hopefully the vacuum pump will stop. Okay, so it's covered the EC, or the salinity meter, and we've just got a delay here for about a minute while the air bubbles come out of the water. Sometimes if you're pulling from a long way, the vacuum it'll make the air come out of solution, and it's not real good to have the air bubbling through the system. So the next thing that will happen, this programmable logger will trigger this gate valve. It's a ball valve to open, and it'll start running through the machine. Do you want to start your computer? Now the earlier models of this, we had a box there with a LED display, so we could read it immediately off. But when it starts releasing, it hasn't started yet, it'll start reading. It'll take 3 readings, and the average will come up. Now the good thing about this is it's fitted with telecommunication, so we can look at it and farmers actually that are using it can look at it on their computer or on the website. It's transferred to a website, so you can Google it, or as Tiffany will show you later, you can get an app on your phone, so you can actually see what's coming off your farm or your group of farmers or whatever it is at any point in time. I'm sure you'd all love to wake up in the middle of the night and check, wouldn't you?
Well, I'm at the Gold Coast, Tom, yeah.
Yeah, if you're down the Gold Coast or the Greek Islands,
Yeah.
So there it goes, it's starting to, that noise you hear is that ball valve opening, and it'll start reticulating through the system and come out here. This normally just goes to waste, but we're catching it because it's the standard and we have to do 3 more runs. So it's, I just made up a rough standard about 25 or 27 milligrams per litre, just so we got some readings. And Tiffany will explain to you a little bit about what is acceptable to let go of your farm, but users acknowledge that any nitrogen leaving the farm is just a waste of money. But I must say that the amount of nitrogen that causes environmental damage isn't a lot in terms of kilograms per hectare. But so I don't think the reason for reducing the losses should be economic, because it's probably not going to worry you a couple of bucks a hectare. But environmentally, when you add, if every farmer lost 10 kilograms a hectare over the whole vertical, it wouldn't be hard for the scientists to work out that there's 60 tonne going out to the reef, and that's what they can easily do that. So I guess the main point of this is to give the farmers the information that the Great Barrier Reef haven't really got, but they'll guess it anyway. So if you've got the information, then it's your opportunity to do something about it. Whether you adjust your management practices, and after doing it for 2 years, we can pinpoint a couple of opportunities to reduce the losses. Very simple things you can do. For instance, the plant crop, runoff from the plant crop is generally the big danger, the big risk. So, as you can see there, I think it's still running through, but it's taken 3 samples.
Got about 10 minutes left.
10 minutes? Good. I better give Tiffany a go. And you'll hear, after it finishes taking the samples and done the averaging, it'll wait for it, and then it'll jet blasts of air across the nozzles, because it's very important that the optics are kept clean. So this is a compressor, and it's got a little tank there, and it'll shoot 2 blasts of bubble air across the lens, and that keeps it clean, because if it got plaqued up, we'd get bad readings. So, it's the best thing, this machine